of it. On behalf of the Canadian Museum of Nature, thank you for coming. I would now like to welcome Dr. Sam Shiner, Chair of the Gould Award Committee of the Society for the Study of Evolution, who will introduce our guest speaker. Merci de prêter votre attention à moi et bonne soirée. Je vous souhaite un très bon congrès. Merci.
Bonsoir, good evening. So for those of you from the general public who might be here this evening, just a word about the conference. So this is Evolution Ottawa, and it's a joint meeting of 5 different societies: the Society for Systematic Biology, the American Society of Naturalists, the Canadian Society of Ecology and Evolution, the European Society of Evolutionary Biology, and the Society for the Study of Evolution. And as the chair of the Gould Committee for SSE, I'm very pleased to announce this year's winner. The Stephen J. Gould Prize is awarded annually by the Society for the Study of Evolution to recognize individuals whose sustained and exemplary efforts have advanced public understanding of evolutionary science and its importance in biology, education, and everyday life in the spirit of Stephen J. Gould. The winner of the 2012 Stephen J. Gould Prize is David Quammen. Mr. Quammen is a prize-winning author who has done much as a science writer to advance understanding in the public of evolutionary biology. His 1996 book, The Song of the Dodo, won both the John Burroughs Medal for Nature Writing and the New York Public Library Helen Bernstein Book Award. It artfully portrays the history of the field of evolutionary biology, including the efforts of Darwin and Wallace, as well as contemporary scientists such as E.O. Wilson, Dan Simberloff, and Ted Case. His 2006 biography, The Reluctant Mr. Darwin, captures Darwin's life story and how his experiences shaped the development of his ideas. He is also a renowned science journalist and nonfiction writer, for the past 30 years introducing readers to evolutionary ideas and other wonders of nature in magazines as diverse as Outside, National Geographic, Smithsonian, Harper's, The Atlantic Monthly, and Rolling Stone. His writing is always lucid, detailed, and accurate, containing details that will educate experts and non-experts alike. Previous awards include the Academy Award of Literature from the American Academy of Arts and Letters, the Lannan Literary Award for Nonfiction, and the Penn Spielvogel Diamondstein Award for the Art of the Essay. His most widely read piece was the November 2004 cover story in National Geographic, Was Darwin Wrong? That was awarded the National Magazine Award. For all these reasons, it is extremely fitting that Mr. Quammen received the Gould Award. Now, to present the award will be Scott Edwards, the president of SSE. David, Scott. So the award consists of not just this very nice trophy, but also a check for $5,000. So congratulations.
Thank you so much.
You want to put it in the box?
Yeah.
Okay.
Thank you. Wow. Hi. This is great. This is great. I love big audiences. especially big audiences filled with evolutionary biologists, and with members of the Ottawa public. Welcome to you, and thanks for being here with us, for caring about this stuff with us. This is really thrilling to me, because when you write about science for the general public, you always look over your shoulder and ask yourself, well, what are the scientists thinking? Am I getting this wrong? Am I getting this right? Are they rolling their eyes and clutching their heads as I try and explain this stuff? And I appreciate your telling me that I'm getting an okay. I appreciate it very much. I want to thank very warmly the SSE Council, all those 5 organizations that are gathered here for this meeting, particularly at the SSE Council and the Education Committee of the SSE, and Scott Edwards, Sam Shiner, Howard Rundle, Andrew Simons, everybody who's been involved with this award and putting this meeting together. I'm very, very grateful. Those of you who are here for the meeting, you're going to see a lot of PowerPoints, I suspect, in the next 2 or 3 days. Would it be all right if I don't show you any slides and graphs? I don't think, okay, good. I'm just going to talk. I just want to look at you and have you look back and tell some stories and offer some thoughts. I'm not going to do anything fancy. I'll talk for about 35 or 40 minutes, and then maybe if we're allowed, we can have some dialogue back and forth. I'll be happy to take questions. I want to begin with a few words about the man for whom this award is named. And then I'm going to draw a little bit from my own experience of trying to chronicle and elucidate science, especially evolutionary biology, for the general public. Science writing is not rocket science. It's not even rocket science when you're writing about rockets. And I'm just going to make one very simple-minded, fundamental point in my talk about that, and I'll give you a hint. It's about people. That will lead me to a subject that I can't resist touching on because it's occupied most of my attention for the past 6 years. And also because it's perfect for a light, welcoming, after cocktails, first evening of the meeting chat for a room full of biologists. Emerging zoonotic diseases. But before I get into that, Stephen Jay Gould. Stephen Jay Gould was a scientist who wrote, although based on his output, his success at reaching audiences, his informal and personable style, a reader might be excused for taking him as a writer who did science. He loved the process of science. He loved the data gathering. He loved the shaping and testing of ideas, loved the insights that science produces. But he also, I think it's safe to say, loved the human element. He loved the foibles of human character and the drama of human efforts to understand. He loved the arguments. He loved the obsessions. He loved the heroic failures, the dead-end journeys, as well as the discoveries and triumphs. And I suspect that's part of what drove him to practice the craft of history as well as the science of evolutionary biology. He liked to write about people, telling bits of their human stories within the great saga of science. One way of gauging that, by the way, would be with his huge final opus, The Structure of Evolutionary Theory, which came in at 1,343 pages, not counting the bibliography and index. As those of you know who have read that massive, rich, overfull book. If you cut away all the touches of scientific biography, all the humanizing digressions in that book, which would be, by the way, a bad mistake, it would probably come in at only 800 or 900 pages. His first book of essays, Ever Since Darwin, which happens to be the one that most influenced me, is a book filled with characters as well as facts and ideas. He wrote about Darwin and Lyell and Huxley, of course. Also wrote about Fitzroy and Linnaeus and Richard Owen, Louis Agassiz. And he tossed in Groucho Marx, Mel Allen, Jim Arness, Friedrich Engels, and the Victorian lyricist W.S. Gilbert. If you dip into his second volume, the second collection of essays, The Panda's Thumb, you'll find Isaac Walton and Odysseus, Alexander Pope and Muhammad Ali, Florence Nightingale, Karl Marx, Mickey Mouse, Ted Williams, among others. By the way, does writing about Mickey Mouse constitute a humanizing element? I guess that's a little ambiguous. Why was Gould's cast of characters so broad? Because he wrote for readers, not for the record. He understood, very, very simple point, he understood that people like to read about people, even when they're reading about science. That's one of the lessons I learned early from him and from a number of other writers about science writing from the general public. You can't just explain things. You can't just present facts and ideas and results in lucid, everyday language. You can't just simplify the complex. That's not enough. Not if you hope to bring large audiences of non-scientific readers into engagement with the substance of science. You need to do all that, plus something else. You need to tell human stories. And I know that Sean Carroll talked about that 2 years ago when he accepted this award, storytelling. Stories about people. People like to read about people. Now, for another instance of that obvious but important truth, I'd refer you to David Hull's great book, Science as a Process. That book, Science as a Process, is a case history of just what its title declares, the process of science, exemplified by the rise of cladistics. Now, forgive me for saying this in front of a room full of biologists, but a history of cladistics could be just a little bit dry. David Hull's book isn't. It's lively, it's engrossing, because it's populated with flesh and blood people, real human characters. Their ambitions, their convictions, their jealousies, their grudges, their alliances, their schemes. Science as a Process is serious history, rich with evidence and analysis, but it's also good reading, lively intellectual entertainment, sort of like a soap opera on the history of cladistics, because it's full of human story. People like to read about people. And at the risk of making you self-conscious, I'll point out that you people are among the people that those people most want to read about. It may be true, as the Gallup poll tells us, alas, that 46% of the American public decline to accept the reality of human evolution, 46%. And that's, we all know, that's consistent over the last 30 years. But that still leaves half of all Americans and many other readers around the world who recognize not only the reality, but the majesty, the fascination, and the drama of evolution, including human evolution. And that's a pretty good potential audience for what I and my colleagues can say in print about you and your colleagues. We have the advantage of a great subject, a far-reaching story that's full of mystery and surprise. It's a magnificent intellectual edifice with a rich history of disputation and truth-seeking and self-correction. Readers recognize that this particular field of science, the past and ongoing efforts to understand what Evelyn Hutchinson called the ecological theater and the evolutionary play, that this is one of the most thrilling enterprises that humans have ever undertaken. But see, it comes back around to humans, right? Now, I don't want this to sound anthropocentric. I dislike anthropocentrism as much as the next person who grew up with an adoration for snakes and insects. It's true, it's absolutely true that we have too much anthropocentrism cooked into our habits of thought and our systems of value on planet Earth. But I'm a realist on the matter of reaching an audience with written works. People are the ones who read. If I write an article about sequoia trees for National Geographic, as I've recently done, sequoia trees are not going to read it. If I write a book about island biogeography, Komodo dragons are not going to read it. Forgive me for stating anything so blindingly obvious, but it does bear remembering people are the audience, and people like to read about people. Evolutionary biology is a great subject for a science writer because besides being important, besides being complex, besides being intellectually rich, it has attracted, as a profession, a lot of very interesting people. Brilliant people, brave people, controversial people, some wacky people. The field is full of great protagonists as well as great ideas. It's been my good fortune over the past 30 years to follow that profession as part of a journalistic and authorial beat. And it's been my privilege, the same privilege that all science writers have, to meet, to study, and to pick the brains of some wonderful biologists. I should note that there are essentially three levels on which those encounters between the scientist and the science writer, three levels on which they can happen. The first level, the minimal level, is that you get the scientist on the telephone for a conversation. Maybe you talk for a half an hour. Now, in our hectic world today, with scientists facing all their academic pressures, their research schedules, all their own deadlines and demands and distractions, a half hour on the telephone is a pretty big deal. We are grateful. You can get some nice insights, you can get some background, you can get some quotable quotes in a half hour of scribbling notes with a receiver crimped to your shoulder. I've had that sort of good half hour with a lot of fine scientists. I've had it with James Watson on the subject of the schism between molecular biology and organismic. I've had it with Richard Wrangham on the subject of bonobo evolution and the really suggestive, interesting fact that bonobos are not sympatric with gorillas. I've had it with Jonathan Lassos on the subject of adaptive radiation among Caribbean lizards. It's great, but still, that level is just a first scratch on the surface of getting to know a scientist. The second level is when you darken the door of the scientist's office or lab. This allows you to see them as well as to hear them, and that can help in establishing rapport or a certain amount of trust. But it's equally important that that office visit allows you to see them in their habitat, at least their indoors habitat, their thinking environment, their little secret den. You take note of the books on their shelves, the pictures on their walls, the souvenirs and paraphernalia they've collected, the Charles Darwin plush toy, the action figure of Batman, the stuffed Galapagos tortoise. You see their particular taste in Gary Larson cartoons. A visit like that can tell you things that a phone conversation can't. When I first visited Dan Simberloff in his office, for instance, I saw things. I already knew that Dan Simberloff was this wicked smart, hard-headed, null hypothesis skeptic of loose ecological thinking, loose ecological theorizing in particular. And then I got to his door and I found it festooned with newspaper clippings. The door was closed when I got there, so I had some time to look at these clippings, and I saw that they were all about pious Mexican women who had each spotted the face of Jesus in a frying tortilla. Different stories, different women, same face of Jesus. So, seeing pattern where pattern was an illusion, arguably an illusion, I think an illusion. Get it? So, right there, I had learned something about Dan Simberloff. I had learned that he doesn't just have convictions, he has convictions plus a sense of humor. Likewise, when I called on Edward O. Wilson, this was back in about 1991. I was researching my book on island biogeography. He didn't know me from Adam. I showed up at his lab for the interview, and I saw a row of framed photos high across one wall with these serious-looking men in them. John Morton Wheeler and other scientific elders. On the opposite wall, equally high, 5 other frames. In each frame was the photo of an ant. Wilson was very welcoming. Call me Ed, he said. It was lunchtime. He'd bought turkey sandwiches for us, pulled them out of his refrigerator. I got some turkey sandwiches. Will these be okay, David? I've got baklava for dessert. Lingonberry juice, is that going to be okay? Yes, Dr. Wilson, that will be okay. No, call me Ed. Okay, all right. And then he took me next door to a seminar room, and he gave me a personal showing of his slide lecture on the foundations of island biogeography. Slides come up. One slide comes up. There are a couple people on a sun-blasted beach. That's Robert MacArthur there, he said. The one in the chinos with the baseball cap pulled down over his face. So I had learned 2 things. I had learned that Robert MacArthur hated to be photographed, and I'd learned that the great Dr. Wilson is a sweet-spirited, generous, unpretentious man. The third level of encounter with a biologist is to spend time with him or her in the field. This is the best and most satisfying way, to be out there crashing around in the forest or in the desert or in the island for days or weeks. It's definitely my preferred mode. My usual approach is to shadow the scientist doggedly, trying to interfere as little as possible with the work, to observe the what and the how, pepper the poor man or the poor woman with questions, and scribble notes on virtually everything of potential significance or potential amusement that he or she says. In other words, I give each scientist a small dose of the same pestiferous attention that James Boswell gave for 21 years in 18th century London to the famous literary man, Dr. Johnson, Samuel Johnson. Boswell's observing, his listening, his note-taking eventually yielded his great biography, The Life of Johnson, which some critics still consider the greatest biography in the English language. Boswell is such a paragon that his own name has become a verb and a participle that the rest of us can decently use. This good fortune, this opportunity of Boswelling some of the world's most intriguing biologists, is the sort of blessing that comes as a rose amid thorns. It comes with travails and responsibilities. Sometimes that means physical challenges, such as tromping through a jungle behind a researcher who always seems to be younger, more fit, more heedless of discomfort and danger than you are. Case in point, a certain field-toughened, half-crazed, and magnificently dedicated tropical ecologist named J. Michael Fay. Mike Fay, some of you may have heard of him. Mike Fay is the man who made an epic foot-slog journey through the last remaining pristine or nearly pristine blocks of Central African forest. This is back in 1999 and 2000. He walked from the northeastern corner of the Republic of Congo to the Atlantic Ocean, 2,000 miles. And he didn't just walk, he bushwhacked 2,000 miles, moving with a team of about a dozen Bantu and Pygmy crewmen. They carried the tents and the food and the computers. Fay carried a backpack, a video camera, and a Write in the Rain notebook with a pencil. He followed a compass line that he'd plotted to avoid all the human trails and the villages. He crossed swamps and rivers and thickets so dense that sometimes he made only a mile of headway in a day. It took him 456 days. He did it all wearing river shorts and a pair of Teva sandals. He crossed the Congo River Basin, across the north of the Congo River Basin, topped over a low divide into Gabon, and then continued across another river drainage to the Atlantic. Now, this wasn't just a demented lark. It was a demented lark, but it wasn't just. It was also a biological transect, a systematic sampling of animal and plant diversity in those blocks of forest. He took data every step of the way. He wanted to know what was there. He called it the megatransect. My job on assignment for National Geographic was to accompany Fay for sizable stretches of this trek and to write about it in a 3-story series, which appeared in 2000 and 2001. I spent about 8 weeks in total shadowing him on the trail through the forest, and I learned a lot during those 8 weeks, I can tell you. I learned, for instance, that river shorts and Teva sandals were the way to go. You couldn't wear boots and long pants and follow him where he was going, keep up with him as he crossed the muddy swamps and the blackwater streams up to your armpits and the soggy clearings in the forest full of sedges and forbs and gorillas. I learned to carry a bottle of iodine for all the cuts and scratches. I learned to duct tape my feet underneath those sandals, covering just the hot spots and the wounds. I learned that Mike Fay was an obdurate loner who could be very difficult and obnoxious. And I learned that, difficult or not, he was a wondrous biologist and a passionate conservationist. I learned that he was extremely devoted to the welfare of his men and the success of his mission. I learned that he could stop the charge of a forest elephant, at least sometimes, by waving his arms and hollering, calling its bluff. I could tell you a lot of stories from this exercise in Boswelling about the elephant charges, about the naive chimpanzees with no fear of humans that would come into our camp, about the tent-eating termites and the gaboon vipers that turned up underfoot, about the driver ants. Imagine putting your foot down into a column of African driver ants by mistake while you're wearing tivas and shorts. But I'll limit myself to one little moment because I'm charting this talk from the Congo to the virosphere, and I want to mention the part about Ebola virus and gorillas. During the middle stretch of Faye's trek in northeastern Gabon, he and I walked through an area known as Minkebi Forest. It's just near the headwaters of the Avindo River in northeastern Gabon. And on the Avindo River, east of this forest block, is a village that had suffered a horrendous Ebola outbreak in 1996, just 4 years before we came through. The village was called Mayabut 2. Mayabut 2. It's famous in the annals of Ebola. The outbreak in the village had begun when some village boys went out hunting, and they came back with a carcass of a chimp. Great celebration. Hey, we're great hunters. We've got a chimp. The chimp carcass was butchered and eaten. 31 people got sick. 21 of them died horrible deaths. And later investigation turned up the fact that the boys actually hadn't killed the chimpanzee. They had found it lying dead in the forest. And the chimp carcass evidently had been hot with Ebola virus. Now, we were there in the forest. Two of Faye's crewmen on the hike had their roots in that village, Mayabut 2. There was a talkative guy named Tony, and there was a very quiet, big, muscular, shy guy named Sofiano. They had both been there at Mayabut 2 during the outbreak. And one night, we sat together around Faye's campfire, and they told me about it. Sofiano had lost 6 family members. A niece had died in his arms, bleeding. He hadn't gotten sick. At the time, none of them, those 2 guys, or none of the people in the village knew anything about Ebola. They didn't know it was a zoonotic virus hiding somewhere in some species in their forest. They didn't know that it affected apes as well as humans. They didn't know what was causing all this misery and death. But Tony, the gregarious one of the 2, remembered having noticed something weird at the time, and he told me about it. Around the time of the outbreak, he told me, he and Sofiano had seen a pile of 13 gorillas lying dead in the forest nearby. 13 dead gorillas near the outbreak village. That image stuck in my memory like an arrow. It was that moment, 12 years ago this week, that I got interested in the subject of zoonotic diseases. So, zoonotic diseases, the diseases caused by pathogens that pass from non-human hosts into humans by a process the scientists call spillover. Everything comes from somewhere, and most of our infectious diseases come from wildlife. According to one study, 58% of human infectious diseases are zoonotic. And that study just considers pathogens of relatively recent origin. Once they've been with us for a long time, we think of them as ours. Measles, for instance. Measles may have reached us in the form of the rinderpest virus from our cattle thousands of years ago, but it evolved. It diverged from rinderpest. It specialized in humans, and nowadays it's not considered a zoonosis. Falciparum malaria seems to have made the leap from gorillas, from being a vector-borne, a mosquito-borne gorilla disease to being a mosquito-borne human disease. HIV 1 group M, which is the pandemic strain, which is the one that causes the AIDS pandemic, HIV 1 group M, came to us as a chimpanzee virus, probably as far back as 1908. Ebola in humans was unknown until 1976. I decided 6 years ago to write a book about this subject. These are fascinating ecological relationships with dire implications, raising all sorts of important evolutionary questions. But you can't just write a book about ecological relationships and evolutionary questions. Not if you want it to be read by the general public. People want to read about people. So you turn your attention, if you're me or a writer like me, you do anyway, you turn your attention to the people, the ecologists and evolutionary biologists who study viruses. This is not a constraint, it's an opportunity. In my case, it's led to all three of those modes of encounter: the phone interview, the office visit, the field time, with some great senior researchers, some great world experts, and some sharp young scientists in the fields of viral ecology and viral evolution. Now, viral evolution, do viruses evolve? Scientists don't even completely agree about whether or not viruses are alive. But yes, they do evolve. Viruses certainly evolve. Whether we consider them living creatures or just mechanismic, suborganismic somethings, they certainly evolve. They possess genomes. They replicate. In replicating, they mutate. Mutation gives them plenty of variation within their populations. They compete for resources. They suffer selection. Therefore, they evolve. Among the leading thinkers in this branch of evolutionary biology is a man named Edward C. Holmes of Penn State. Holmes is the man who wrote the book on the evolution of RNA viruses. And I mean that literally. The book is titled The Evolution and Emergence of RNA Viruses. It's a little red volume full of scary and amazing things, published in 2009 by Oxford U Press. Holmes focused on RNA viruses because those are the ones that cause most of the scary new diseases. They emerge readily from their animal hosts. They mutate at high rates. They adapt quickly. They show themselves in spooky disease outbreaks. And they carry the highest potential for causing the next human pandemic. The list of notorious RNA viruses includes Ebola, Marburg, West Nile, the influenzas, the hantaviruses, dengue, yellow fever virus, rabies, SARS coronavirus, HIV-1, HIV-2. That's just for starters. It also includes some lesser known but nasty bugs that have emerged within recent decades and which the disease experts are watching closely. Something called Nipah virus in Malaysia and Bangladesh. Something called Hendra virus in Australia. Plus Lassa virus, Machupo virus, Australian bat lyssavirus, chikungunya, and a number of others. If you want to understand the origins of AIDS and what that pandemic has in common with Ebola in the Congo, with the 1918 flu pandemic, with the SARS outbreak in 2003 that scared the bejesus out of disease scientists around the world, and with the next human pandemic, the one that's going to come out of some inconspicuous reservoir host in some tropical forest and kill millions of people, maybe next year, maybe 5 years from now, the one that we don't know about yet. If you want to understand that altogether, you need to understand a little bit about the evolution of RNA viruses. And that's why I went to visit Edward C. Holmes. He's an Englishman transplanted from London and Cambridge to State College, Pennsylvania. He's got a nice round head, and he keeps it shaved bald. He wears glasses with thick, dark frames. His eyes bug out slightly when he discusses a crucial fact or idea, because good facts and good ideas impassion him. He looks brilliant and austere, but he's not austere. He's lively and funny. Everybody calls him Eddie. His office is a little room, nearly bare, at Penn State. At least it was when I visited. It's a thinker's room. It's not a lab or a library. It contained very few bookshelves, a couple of chairs, a computer with a large monitor. And on the wall, above Eddie's desk, were two pieces of art. One was a poster celebrating the virosphere. And you've probably seen this image. It looks like a very colorful flying saucer representing the total viral diversity on Earth. It's cut into segments, actually maybe more like a pizza than a flying saucer. And each of the radial pizza segments represents a proportional contribution to the whole of different groups of viruses. Single-strand RNA viruses, double-strand RNA viruses, DNA viruses. It's all there, celebrating the earthly diversity of viruses. And right beside that poster on Eddie's wall was another poster. This one showed Homer Simpson portrayed as a character in that painting, Edward Hopper's Nighthawks. You know the one I mean? They're in the diner. It's late at night, bleary, smooth surfaces. There's also a parody version of it with Elvis and Marilyn Monroe. But this is a parody of Edward Hopper's Nighthawks with Homer Simpson sitting at the counter with a big pile of donuts in front of him. And he's wolfing them down. I'm not sure what that one celebrates, except donuts. So I spoke with Eddie Holmes for about an hour, and I learned a lot from him about the evolution of RNA viruses. Fascinating subject, important subject. RNA viruses, fast replication, small genomes, high mutation rate, acute infections, boom and bust population cycles, abundant genetic variation, therefore fast evolution, as with the influenzas. RNA viruses versus DNA viruses, such as herpes zoster, shingles, chickenpox. Slower replication, larger genomes, low mutation rates, chronic infections, long periods of dormancy, life history strategies more tuned toward persistence and stealth. Slower evolutionary change. There are huge consequences to these differences in evolutionary style. One consequence, as Eddie told me, is that RNA viruses are far more likely to switch hosts, to spill over from a non-human animal, get into humans, adapt, cause a disease outbreak, maybe an epidemic, maybe a pandemic. Now, I can't do justice to this subject in a few sentences or a couple of paragraphs, and I've talked long enough. For more on RNA virus evolution, I recommend to you Eddie's book, The Emergence and Evolution of RNA Viruses, or better still, maybe you'll read his book and my forthcoming book on this whole subject, which is, I'm shameless enough to tell you, will be published in October, entitled Spillover. But I want to finish here, instead of going deeper into that, with just one more glimpse of the humanness of a formidable scientist. The scene that I just described, the visit with Eddie in his Spartan office, talking about RNA viruses, appears in chapter 5 of my book. And during the rewrite process, I sent the draft pages to Eddie. And I usually do that with my scientific sources, send them pages and say, please mark this up, please correct this if you would. So I asked him to read and correct. Some writers, some science writers, some journalists decline to do that as a matter of principle. They will not show drafts to their sources, even if they're writing about science. They worry that showing a draft to your sources compromises your journalistic independence. I don't think so. I think showing a draft to your scientific sources means that you have a better chance of being accurate, and that's so important. So I've done this, and I've found that scientists, I'm not trying to flatter you, but scientists, biologists that I've dealt with, are very, very capable of distinguishing between what I'm asking them to correct and what I'm not asking them to correct. Very capable of distinguishing between factual mistakes and subjective judgments. The mistakes need to be corrected. The subjective judgments are the writer's prerogative. I've had really good experiences getting these kind of factual critiques from scientists who are self-confident, clear-minded, and don't try to mess with my spin. And Eddie Holmes was no exception. He read my whole chapter on viral biology, including viral evolution, and he made a small number of very welcome corrections. We were sending back and forth an MS Word file. And so his notes appeared as those little comment balloons in the margin. In his case, they were little green comment balloons. And when he came to the section about my visit to his office and the Virusphere poster and the poster of Homer Simpson and my rhetorical question about what that might be celebrating, except maybe donuts, Eddie Holmes put a little green comment balloon in the margin, and it said, "My physical and intellectual resemblance to Homer." Thank you again for this wonderful award. Thank you, Eddie Holmes, for being brilliant and unpretentious. Thank you for all of your tolerance of science writers. Thank you for allowing us to Boswell you. And most importantly, thank you for the fabulous work that you do.